Welcome and thank you for joining. Let's work together on sample applications of linear systems. This is part 2 of our word problem set, and our focus will be on distance, time, speed questions and the mixture questions. So let's get started with our first example. So as always, we're going to follow the same strategy. We're going to read the problem first to get an idea what it is about. So a plane flew to Kampala with a tailwind plane, average 158 kilometers an hour, and on the return trip, the plane averaged 112 kilometers an hour while flying back into the same wind. Now we have to find the speed of the wind and the speed of the plane in still air. So I read the problem the first time. I understand this is a distance, time, speed question. We know that speed equals distance over time. If you ever forget the formula, always think how we measure speed. So speed is always kilometers per hour. And remember that in kilometers, we measure distance. So that means that the number on top has to be distance. And in hours, we measure time, so distance over time. So it's impossible to forget it. Now, we're going to read the question one more time. Our focus will be on the final question asked. So we have to find the speed of the wind and the speed of the plane in still air. If you remember, we said that the things that are asked in the final question are the things that we're going to name as X and Y, and that is, I would say, not 100% of the time, but probably 90% of the time, so most of the time. So we're going to let the speed of the wind be represented by W, and we're going to let the speed of the plane be represented by, we're going to call this A. Probably it's a good variable, actually. So now we're going to reread the problem, and at least we have a name for everything we're given and everything we're trying to find. So the names can be in forms of numbers or in forms of variables, but we can read the problem the second time with more clarity this way. So a plane flew to Kampala with a tailwind plane. So what does it mean with a tailwind? So with a tailwind means that the speed of the plane and the speed of the wind are going in the same direction. So if you can imagine yourself walking on a windy day, if the wind is behind you, so you're going with the speed of the wind, you're going to tend to walk faster. So that is because your speed is, fueled by the speed of the wind as well. So what that means is that when you fly, when the plane flew from with the tailwind, then the total speed will be W plus the speed of the plane. So, and the average speed was 158 kilometers an hour. Now, on the return trip, the plane was 112 kilometers an hour while flying back into the same wind. So again, I would like you to imagine yourself into a similar situation. This time, though, you're not walking with the wind, you're walking against the wind. So your actual speed is slowed down by the speed of the wind that you're facing. So we're going to say that in our case here, the airplane speed will be decreased by the speed of the wind. And the average speed here was 112 kilometers an hour, and the word average in here is used in the context of the overall, so you can actually use the word overall in general. So we're going to say that if the speed of the plane with the tailwind is 158, it means that the speed of the plane plus the speed of the wind will equal 158. And next we have the speed of the plane decreased by the speed of the wind. So A minus W is equal to 112. So we have formed a system of two equations. We are asked to find A and W, and I think we're ready now to solve the system. So as you can see here, W and negative W, they are same terms, opposite signs, so it will be easier to solve this system by adding the two equations. And what we're going to get here is the speed of the plane plus the speed of the plane down here, then plus the speed of the wind plus the negative speed of the wind, and then equals 158 and then plus 12. So we are adding all the respective terms in this case. And we're going to simplify, obviously, these two. That's why we added the equations. And we have 2a equals 158 plus 112. That would be equal to 170, if I'm not wrong. Double check. 8 plus 2 is 10. 5 plus 1, 6, 7. And 270. And then we're going to divide both sides by 2 to isolate a, and we get 270 divided by 2, 135. So if a is 135 and a plus w is 158, that will make w equal to 158 subtract a, or 158 subtract 135. And that would be equal to 23. So w is 23. Lastly, we are going to state the final answer, or the therefore statement here. And we're going to say that the speed of the plane is 135 kilometers an hour, and the speed of the wind, or wind speed, is 23 kilometers an hour. And always be very careful with including the unit measurements, especially in the final statement. So that was example number 1. In the next example, we're going to work on another distance, time, speed problem. And as always, I'm going to write the formula that connects all of them. So we say that this is the easiest one to remember. The speed equals distance divided by time. So kilometers an hour, that's how I remember. And now by rearranging this formula, you can create other formulas. So distance equals speed times time. So speed times time. Or we can say that time equals distance over speed. Now, depending on the question, so if you want to isolate t, you divide by s, both sides, by speed. Now, I would write all three formulas because depending on the information given, I may need to use one or the other. So now let's read the problem again. A boat traveled 210 miles downstream and back. Now the trip downstream took 10 hours and upstream it took 15 hours. What's the speed of the boat in still water? What's the speed of the current? So as you can see here, we have two questions asked: the speed of the boat and the speed of the current. So guess what? The speed of the boat is going to be one of the variables. So we're going to call this the variable B. And the speed of the current, let's call this the variable C. Now, usually I like to create a chart especially for these type of questions when we're going with or against current. And this is optional, but I find that this actually makes the solution a lot clearer, and it helps with getting to the right answer, most of the time. So create a chart with distance, time, and speed. And we have two situations, downstream and upstream. And you reserve the last row for the relationship that exists between the downstream and upstream motions. So about distance, you see that the boat went 210 miles downstream. So I'm going to write in here 210 miles. And it went also backwards, so it went downstream, upstream, and the distance is the same when you go upstream, so 210 miles. So there is no relationship between the two besides the fact that they are equal. Now we're going to talk about the time. Now the trip downstream took 10 hours, so that's 10 hours. And the trip upstream took 15 hours. Now, we need to know what the speed will be for the boat and for the current. Now, remember that when the boat goes downstream, the current is moving with the boat. So that means that the total speed would be equal to the speed of the boat increased by the speed of the current. When the boat goes upstream, the speed of the boat is decreased by the speed of the current. So we don't form relationship between the speeds in here, like any relationship between these two, okay? But what we can connect in this case is the distance, time, speed together. So you know that distance would be equal to time times speed multiplied by speed. And as you can see here, you have 210 miles equals 10 times B plus C, and 210 miles when we went upstream is 15 times B minus C. So these are the two equations that we are going to need. So this is the first, and this would be the second equation. Okay, so we're going to write them down here, and I prefer to write this part on the left side. It doesn't really matter. So 10 B plus C equals 210, and 15 times B minus C equals, again, 210. Put them together. Now, I would try to reduce the coefficients as much as possible. You see that we have 10 and 210 in here. They're reducible by 10. So I would divide every term in the first equation by 10. I mean, both sides by 10. Remember that this is a factor, so you just divide by 10 the coefficient here, right? And that will give me, so the tens will simplify, and it will give B plus C equals 21. Now, in the next equation, I see I have 15 and 210. Now, 10 is not a common factor, but 15 might be. So in this case, I would divide both sides of the equation by 5. And let's see where this takes us. So now we're going to have, instead of 15 over 5, 3. So we have 3, and then B minus C equals, and then we have to divide 210 by 5. And that will give 42. So this system is a lot easier to simplify than this one here, or to solve than that one. So what we're going to do next is, 42 divided by 3. Oh, that's divisible as well. So this is an adjustment that we're going to make. I'm so stressed about the time now. That's one thing actually that affects how fast we do things. But let's try to divide by 15 both sides, because it seems that they're divisible. And we notice that in this case, we're going to end up here with B minus C on the left side, and 210 divided by 15 is equal to 14. Now, see how we have C positive and negative, so we're going to add the two equations, and then that will result in 2B plus no C, 0C, because plus C minus C equals 0, 21 plus 14, and 21 plus 14 is equal to 35. And right now we have B equal to 35 divided by 2, or B equals 17.5 kilometers an hour. That would be the speed of the boat. And we're going to look into the speed of the current. If B plus C is 21, then C is 21 minus B, or 21 minus 17.5. 21 minus 17.5 would be equal to 3.5. So that would be the speed of the current. So therefore statement, so the speed of the boat is 17.5 kilometers an hour. Here goes music again. And there goes our distraction. And the speed of the current is 3.5 kilometers an hour. Okay, so I hope that you found these instructions helpful as always, and continue practicing the rest of the questions. Follow for more videos and for more explanations. Bye for now.